All right, so the purpose of this video is to review our process of factoring quadratic expressions in standard form, ax squared plus bx plus c. We're going to just go through a couple examples where we put things, how we think about it, kind of referencing our algebra tiles, and how we went from algebra tiles to our generic rectangle. So we're going to start first with factor 2x squared plus 7x plus 6. To factor means to find the factors that will multiply to 2x squared plus 7x plus 6. In thinking of a generic rectangle or algebra tiles, we would build the rectangle from the sum and then find the dimensions or the lengths of each side of that rectangle, which then become our factors. 2x squared plus 7x plus 6. Our first term, 2x squared, is going to go in our bottom left, 2x squared. Our last term, 6, is going to go in the upper right. And that's how we're going to start factoring any of our quadratics. So we're going to take the first term and third term, assuming it's written in ax squared plus bx plus c. If it's not written in that form, we're going to rearrange the terms so that we can have ax squared first and c last. Next, we multiply on the diagonal of our generic rectangle, 2x squared times 6. That makes 12x squared, and that's going to become the top of our diamond problem, 12x squared. The remaining tiles, if we think about them as algebra tiles from our sum, would be our 7x. Now what we're going to do is we need to split those tiles up to fill in the two parts of our generic rectangle, but we know that they have to multiply to 12x squared. We'll refer to that as Casey's pattern from class. So what's going to multiply to 12x squared and add to 7x? 7x coming from our middle term. Well, if we list the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. Now, I'm not ignoring the x squared and the x. I'm just focusing on the factors of the numbers, and we'll fill in the x or the variable as we go. 3 and 4 do both. They multiply to 12 and they add to 7. That's going to go on the side of my diamond. Now here's where I'll fill in my x's. So I know x times x makes x squared, so they each get an x. And when I combine 3x and 4x, I end up with my 7x in the bottom. The sides of my diamond problem, 3x and 4x, are going to be filled in my blank spaces in my generic rectangle. As long as they are 3x and 4x, it doesn't matter which spot they go in, so I'm just going to put my 3x here, and I'm going to put my 4x here. I could switch these around, would end up with the same dimensions of my generic rectangle. Once I have my generic rectangle filled in, I'm going to factor out either a row or a column. I'm going to start with this row. Looking at 2 and 4, I'm going to factor out the greatest common factor of both of those values, 2. I'm also going to factor out an x from x squared and from x, so 2x. Once I have that first piece done, I'm going to build off of it. So 2x times what makes 2x squared? X. 2x times what makes 4x? 2. And then to fill out the last piece, what times x makes 3x? 3. I'm going to double check that 3 and 2 will multiply to make 6, and they do. So I've just found my dimensions or factors of my sum. X plus 2, 2x plus 3. These factors can go in reverse order. We can switch them around with the commutative property of multiplication. In general, too, we'd like to put our variable terms in front or beginning our factor. So x plus 2 as opposed to 2 plus x, 2x plus 3 as opposed to 3 plus 2x. And that's just a universal way to write our factors. This is referred to as factored form. Oh, let's slide that over so you can see that factored form. All right, let's look at another quadratic. Factor 6x squared plus 17x plus 12. In keeping with the same process, I'm going to take my first term, 6x squared in my bottom left, 12 in my top right. Our pattern tells us that these multiply 72x squared, so becoming the top of our diamond. My middle term, 17x, are my remaining piece that need to be split up, so I have to add to 17x. Let's list our factors of 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. I could continue here. However, I'm going to begin to repeat my factors, so I can stop at 8 and 9. Out of these factors, 8 and 9 add to 17. So I'm going to put an 8 here, a 9 here, and they'll both get an x. In keeping with our process, that will fill in the remainder piece of our generic rectangle, 8x and 9x. All right, let's factor out a row or a column. I'm going to factor out a column this time, so I'll do it a little differently. Looking at 8x, 6x squared. 8 and 6, the greatest common factor of 8 and 6 is 2. And I can factor out an x from both terms, so 2x. 2x times what makes 6x squared? 3x. 2x times 4 makes 8x. And 4 times 3 makes 12. Giving me my dimensions of my generic rectangle, or my factors of my factored form. So 6x squared plus 17x plus 12 is equal to 2x plus 3 and 3x plus 4. All right, we'll look at one last quadratic with factor m squared minus m minus 12. Just like any algebraic problem, the variable itself is not important. It can be m, it can be x, it can be a. We'll follow the same process. M squared in the bottom left, negative 12 in the top right. Now, it's important not to lose negatives ever, especially when factoring quadratics. These will multiply to negative 12m squared. And what will it add to? Well, we got to make sure we're careful that this can also be negative 1m. So it's got to add to negative 1m. All right, let's start with our factors. 1 and 12, 2 and 6, 3 and 4. Now I'm focused on positive factors. I can start to then manipulate with positives and negatives to achieve my goal. So looking at negative 12, if I'm multiplying to a negative value, we know that one factor has to be negative, one factor is going to be positive. I also know that these are going to add to a negative 1, which means I need a negative number that when I add to it, it remains negative. So if I look here, I'm thinking which of these are one apart from each other? 3 and 4. The reason I want them to be one apart, I know that if I make my 4 negative, negative 4 plus 3 will make my negative 1. So those are my two parts of my diamond problem. Negative 4m and 3m. And just to double check, negative 4 times 3 makes negative 12. Negative 4 plus 3 makes negative 1. So I feel confident in my factors that I've chosen. Negative 4m, 3m. All right, I'm going to factor this row. I'm going to start with m squared. My only option here is m and m. So now I build off of that. M times what makes 3m. Oh, that got away from me, 3. And m times what makes negative 4m, giving me my factored form of m plus 3 and m minus 4. And this is just demonstrating how we can use our generic rectangle, which we've built from our algebra tiles, to help us factor quadratics.